Welcome to clickmyproject.com. Let me discuss the project about spatially coherent fuzzy clustering for accurate and noise reposite image segmentation. In this paper, we present a new FCM-based method for spatially coherent and noise reposite image segmentation. Our contribution is twofold. The spatial information of local image features is integrated into both the similarity measure and the membership function to compensate for the effect of noise. An anisotropic neighborhood based on phase concurrency features is introduced to allow more accurate segmentation without image smoothing. This segmentation results for both synthetic and real images demonstrate that our method efficiently preserves the homogeneity of the regions and is more responsive to noise than related FCM based methods. These methods to design a method for accurately segments edges and line elements without smoothing. We consider anisotropic neighborhood based on phase concurrency features. The efficiency of the new segmentation method is tested on both synthetic and real images with different noise levels. It's the block diagram of our project. First we will load MRI brain images. The next one is signal noise ratio added for Gaussian noise. The next one is FCM, fuzzy C-mean segmentation. Fuzzy C-mean segmentation, which is an extended version of our performance. We propose an improved FCM based algorithms for accurate and noise deposit image segmentation. In this, we enhance the FCM performance by incorporating the neighborhood information into the similarity measure. While in the new method, we present two improvements. First, to create a method that is more responsive to noise, we incorporate local neighborhood information only into the similarity measure, but also into the membership function. Then second one is this method for accurately segments edges and line elements without smoothings. Then next one is segmentation. This segmentation process is this efficiency of this new segmentation method is to tested on both synthetic and real images with different noise levels. Then the qualitative and quantitative comparison results indicate that our method better reduces the effect of noise than related approaches. The next one is isometric neighborhood configuration. Isometric neighborhood configuration is this method for this important task in the image analysis and is first in these critical steps in many image applications. One of the most commonly used methods in automated image segmentation is unsupervised fuzzy clusterings and remote sensing. The next one is anisotropic neighborhood configuration. Anisotropic neighborhood configuration is this classification decisions is made at this ends. Then this idea is very important in applications where uncertainly poor contrast, limited spatial resolution and noise levels, pixel-wise fuzzy classification with pre-processing. And this integrated them some of this we can calculate the segmentation result. This segmentation influenced by the choices of the similarity measure, which is used for computing the membership degrees values, further used for computing the cluster centers points. Now let's see about the execution part. I am having main.m file. Select the file, right click, then run file. Here we have to select the figure file, then we'll select the load image button. Then here we have to select the input image. The next one is SNR noise, and Gaussian noise will be applied for input image. The next one is remove noise process, then Gaussian filter will be applied for this noise images. The next one is fuzzy C means segmentation. Fuzzy C means segmentations is this proposed methods for this method, and then related approaches are shown on synthetic images. Then this Gaussian noise where signal to noise ratio between the original and noisy images. For the synthetic image, the goal is to accurately segment three homogeneous regions and preserve a line detector. For MR images, the whole way to segment the brain into three classes. Then the next one is proposed segmentation process. Then the proposed segmentation process is very useful to generate at this. Then the gray matter, white matter and professional fluid which can be identified as white, light gray and dark gray diffuse class in the ground truth images. The results show that this standard FCM method has the worst performance and high sensitivity to image noise. The better segmentation is obtained to using the neighborhood weighted similarity measure, but this method is efficient to deal with higher noise levels. The result of our proposed method without using phase concurrency and unstopping neighborhoods indicates that this method is good for segmenting coarse homogeneous regions, good performance for these the noisy images, but is efficient in segmenting line segments. However, by including unstopping neighborhoods in our method, we obtain the best segmentation performance. The next one is select feature map. Feature map is this mapping process is that this both graphs we show the comparison results. The next one is analysis. Then this one is comparison results for the FCM and CA in our previous method and our allostrophic method and unstrophic method. Then this comparison for this second graph additionally show the results of these two popular MRI segmentation methods, FCM based and automated segmentation tools. The experiment results indicate that our method has the highest accuracy in segmenting comparing with the other methods. The same novel FCM based method for accurate and noise opposite image segmentation is proposed. The method integrates spatial contextual information of our neighboring pixels into FCM algorithm using phase concurrency and stochastic neighborhood and adaptive weights for membership calculation. In this way, the proposed method is designed to accurately segment edges, lines and coarse homogeneous regions at the same time. The quantify and qualify experimental results for synthetic and real images show a good segmenting performance, especially for very noisy images, and demonstrate and encouraging for practice application of the proposed method. Thank you.